title of this note is Right Triangle Trigonometry, and your outcome is that you will be able to solve the size of a right triangle in any quadrant. So we're going to look at an example, and we're actually not going to solve it just yet. So we're going to have the tangent of theta equals the tangent of theta equals 1/2, and I'm going to give you a restriction that we're going to solve between pi and 3 pi over 2. And so the question is to solve for the secant of theta. So how are we going to approach this? Before we even start it, let me give you some steps. Okay, so the first thing you're going to do is you're going to draw the triangle in the appropriate quadrant, as we're knowing those angles on your unit circle are going to come in handy. Then you're going to use the Pythagorean theorem, that's a squared plus b squared equals c squared, to solve for the missing side. You want to make sure that when you're labeling your sides, you're using the correct signs for each side based on the quadrant. So this time you have to pay attention to, are your x's and y's positive or negative? And then once you have that figured out, you're going to solve for the correct trig ratio. You might remember the word SOHCAHTOA from your geometry days. That's going to come in handy to solve this. So now let's look back at that example again. And the steps are here. So let me just rewrite this. These symbols are easier to write than type. So we're solving for it. We know that the tangent of theta is 1/2. We know that theta is between pi and 3 pi over 2. And we're solving for the secant of theta. So first we're going to draw the triangle in the appropriate quadrant. Pi, if I think about the unit circle, pi is right here, and 3 pi over 2 is down here. So I'm in quadrant 3. Remember, your quadrants go 1, 2, 3, 4 counterclockwise. So we're going to draw the triangle in quadrant 3. So I'm sketching. Theta always has to be by the origin. And one side of the triangle always has to be on the x-axis. So let's add that to our notes. Theta, the angle theta, is on the origin. And one side of your triangle, one side of the triangle must be on the x-axis. 2 requirements for your steps. So let's label this as theta, the angle that's closest to the origin. We know that the tangent of theta is 1 over 2. Here's where SOHCAHTOA comes in handy. Tangent is the opposite side divided by the adjacent side. And we're talking in reference to theta. So from theta, the opposite side, let me move that. The opposite side from theta is over here. So that's at 1. And the adjacent side is 2 because it's 1/2. So opposite over adjacent. And I want to check my signs. So from the origin, if I'm going left, it's actually a -2. And if I'm going down, it's a -1. So now, step 2, we're going to use the Pythagorean theorem to solve for the missing side, which is right here. It's the hypotenuse. So my Pythagorean theorem says a squared plus b squared equals c squared. I also like to say that it's leg squared plus leg squared equals hypotenuse squared. All right, so one of the legs is -2, one of the legs is -1. It actually doesn't matter if you use the negative sign, because when you square a negative, you get a positive. So 4 plus 1 equals the hypotenuse squared. So that's 5. So if I take the square root on both sides, the length of the hypotenuse is the square root of 5. Because that's a distance back to 0, that's always going to be positive. Your hypotenuse is always positive. It's only the legs that have signs. Okay, so that was step 2. We used Pythagorean theorem. We figured out that the hypotenuse is the square root of 5. So now we're going to solve for our trig. We want to know what is the secant of theta. Secant is the reciprocal of cosine. So cosine, again, thinking about SOHCAHTOA, cosine is the adjacent, let me rewrite that. Cosine is the adjacent divided by the hypotenuse. So the secant would be the reciprocal. It would be the hypotenuse divided by the adjacent. So the secant of theta will be the hypotenuse of that triangle, the square root of 5, divided by the leg that is adjacent to theta, which is -2. We don't like to leave negatives in denominators. I have a positive divided by negative, so I'm just going to pull it out to the side. So the secant of theta is negative radical 5 over 2. So to recap, we drew the triangle in the third quadrant because we were told we were looking between pi and 3 pi over 2. We labeled the 1 and the 2 opposite and adjacent because we know tangent. We used negative signs because we're in quadrant 3. We used the Pythagorean theorem to get the square root of 5. And then we figured out secant, the reciprocal of cosine, is hypotenuse over adjacent, using the numbers from the triangle. All right, so we're going to have one for you to try. You're going to do the cosine of theta. You're going to know that it's 12 over 13. You are going to look for theta in the quadrant where pi over 2 is less than or equal to theta is less than or equal to pi. And you're going to find the cotangent of theta. To get you started, between pi over 2 and pi over 2 is straight up and down, pi is to the left, so we're in quadrant 2. So we're going to draw a triangle. Remember, one leg is always on the x-axis. Theta is the angle by the origin. Cosine is adjacent over hypotenuse. And in quadrant 2, the x's are negative. So now you're going to do Pythagorean theorem to figure out this missing side. It is the side that is opposite of theta. It needs to be positive because it's above the x-axis. And your cotangent is the reciprocal of tangent. Tangent, think of SOHCAHTOA, opposite over adjacent. Therefore, cotangent, which is the reciprocal, will be adjacent over opposite. You already know the adjacent. It's -12. Whatever number you get from Pythagorean theorem will go right there. We're going to check these in class. And that is the end of these notes.